Numbers. A square root of a number is a value that can be multiplied by itself to give the original number. That's the square root of a number. Let's go ahead to explore some simple examples to gain. What is the square root of 144? 144. So to this end, we have our LCM method. Write out 144. Remember, you must divide through with prime numbers. Let's start with the prime number 2. 2 in 1 cannot. 2 in 14 gives us 7. 2 in 4 gives us 2. We take another 2. It's an even number. It can be divided by 2. 2 in 7 gives me 3, remainder 1. 2 in 12 gives me 6. It's also an even number, so it can also be divided by 2. 2 in 3 gives me 1, remainder 1. 2 in 16 gives me 8. It's ending in an even number, so it's an even number. It can be divided by another 2. 2 in 18 gives me 9. Now, it cannot be divided by 2. So we use 3. 3 in 3 gives me 3. 3 in 9 gives me 3. While 3 in 3 gives me 1. So we decide to group it in groups of 2, as I said earlier. Now, here we have one of these 2, one of these 2, and here we have 3. So the square root of 144 will simply become 2 times 2 times 3, which is equal to what? 12. So that's the square root of 144. Easy. Now, we shall be exploring or looking at the square root of fractions. We shall be looking at the square root of fractions and decimal square root of 12, 1 over 4. Now, whenever you're given a mixed fraction to look for the square root, the first thing you must do is to convert a mixed fraction to an improper fraction. A mixed number to an improper fraction, it gives us 4 times 12, gives us 48, plus the numerator gives us what? 49, all over 12. Now, when you look for the square root of 49, you simply ask yourself, what must I multiply by itself to give me 49? Which is simply 7. What must I multiply by itself to give me 4? Which is what? 2 times another 7, all over 2. This take away this fraction. So what we have left is 7 all over 2, which is the same thing as, that means converting it back to improper, to mixed number, please. Convert the fraction back to mixed number. It becomes 3 whole number, 1 over 2. So it is easy peasy. So the square root of 12, 1 over 4 is 3, 1 over 2. Now we'll take our next question for today. For example, we're looking for the square root of 81 all over 121. This is actually easy. So what do I need to do? You look for a number that multiplies itself to give you 81, which is 9, all over what multiplies itself to give me 121 is 11 times 9 over 11. Now, the square root sign takes away this fraction. So what we have left is 9 over 11. That is easy peasy, lemon squeezy, pizza cheesy, Mr. Austin's okra soup. Now we're going to explore the other part of this problem, looking for the square root of decimal figures. We are asked to look for the square root of 0.64. So what should I do? Now, as I said before now, whenever you're given a decimal figure, you write the decimal figure as a fraction with multiples of 0 based on the number of decimals it has. So this decimal figure has tenths and hundredths. So I can simply write it as 64 all over 100. So what I'm going to look for is the square root of 64 all over 100. So this is easy, which is the same thing as the square root of 8. 8 times 8, 64, all over 10, times another 8, all over 10. This takes away this, which gives us 8 over 10. Now we have to convert it back to a decimal figure. This will simply be written as the 0 moves it from here to this place, which gives me 0.8. It's actually easy peasy, lemon squeezy, pizza cheesy, Mr. Austin's okra soup. Now, for better understanding, we shall be taking another question. Let's look at the square root of 0.09. Now, this can be rewritten as the square root of 10th and 100th. So we have the square root of 9 over what? 100. Now, what multiply instead that gives me 9? It is easy, so it is 3. What multiply instead to give me 100 is 10 times 3 over 10. This takes away what? This. And our final answer is 3 over 10. But we need to convert it back to decimal figure. The 0 moves it simply from here to here, which gives us what? 0.3. So with this, we say math is easy peasy, lemon squeezy, pizza cheesy, Mr. Austin's okra soup. See you in our next class.